Okay, so I had to do a minor corrections, right? So get rid of that of, because then or else it wouldn't make sense, right? Get rid of that selecting, that should be selected. Get rid of that a and who. All right. Anyways, okay, so this is the problem that we want to do. We want to go ahead and do this word problem with normal distribution. So this says a large group of students took a test in physics and the final grades had a mean of 70 with a standard deviation of 10. If the grades were normally distributed, find the probability that a randomly selected student scored more than 80. Okay, so that's what we want to figure out. Okay, so the best way to do this problem is look for keywords. So the keywords here, right, is first we had the grades have a mean of 70 and the standard deviation itself is 10, right? And all of the grades are normally distributed, right? So it's very different than this problem because here they basically told us what the random variable was. Our data is normally distributed with a mean of 15 and standard deviation of 3, right? But in this case, right, we don't have that. They give it to us in words, so we need to be able to extrapolate all of this information in order to do our problem, right? So let's say x is going to be the final grade, right? So we say x is normally distributed because that's what they tell us. It's normally distributed with a mean of 70 and a standard deviation of 10. That's what we have. So now we kind of just broke this word problem into something that we already know. Now what we want to do is take this sentence, right, and try to figure out what exactly they want us to do. Now, when we're doing this, right, the best way to do it is always draw a picture, no matter what. Just draw the picture, okay? So let's go ahead and do it. So what do we want? We want the probability that a randomly selected student, so we select someone who has a score more than 80. So if I look here, right, first I know that this is normally distributed. The mean is at 70. This might help us, especially when we're drawing this, right? We know that the center is going to be at 70. All of the, that's where all of the mean is. So what we are interested in is 80. 80 is somewhere around here, right? And what we want is the probability that a randomly selected student scored more than that. Well, where's more? More is all of this. This is what more is. Okay, and we're starting at 80, right? We're not continuing on to 70, right? We're starting at 80, right? Because we want 80 and more. Okay, so now what we got to do now is think about which one should we go ahead and use. Should we use normal CDF or should we use the inverse normal? Okay, so we remember, right? Normal CDF, right? They give us a value, right? And you want to find probability, right? Here, they give you the probability. You need to figure out what the value is. So here, they don't give us the probability. They gave us what the value was. The value is 80, right? So 80 or more, so we're going to have to use normal CDF. So we can write it if you want, probability distribution more than 80, right? We can write it like that if you want. You don't need to. But for the probability that x is more than 80, you have normal CDF. Now my lower bound in this case is going to be 80. So here's 80. My upper bound is going to be something really, really big, which is like 1,000 or 100,000, whatever that is, right? The mean is going to be 70, right? So our mean is 70, and our standard deviation is 10. Okay? So we're going to go to our handy-dandy calculator and try to figure out what this is, right? So I'm going to go into my calculator, right? I'm going to press second data, go to distributions, go to normal CDF, right? Our mean is now going to be equal to 70. Our standard deviation is now going to be equal to 10. The lower bound, so now is 80, right? That's our lower bound. And my upper bound is not going to be something really, really big. You can leave it like 1 times 10 to the 99 power, or you can leave it like that, okay? So calculate, and that's what we get. Our answer is 0.1587. So I will tell you when to round. For right now, just round to 2 decimal places. So I'm going to write that. Round to, no, not 2, I'm sorry. 4 decimal places. Okay. So for right now, just round it till there. Okay, and that's what we get. Okay, that's the probability. So the probability that I obtained someone who scored above an 80, right, is about 15 or 16%, right? That's what we get. All right. Okay, now this problem. What is the 90th percentile? Okay, so what the heck is a percentile? So if you remember in chapter 3, whatever it was, right? Percentiles basically separate the bottom percentage from the top 100 minus whatever that percentage is. So basically, this is what it is. If you are looking for 90th percentile, right, that means that the 90th percentile separates the bottom 90%. That means whatever the percentile is, whatever that value of x is, right, whatever this is, 90% of it is going to be below it. Okay, so that means here 90% or 0.9 is going to be directly below it. Okay, so that means 10% is above it. So if I was looking for, I'm going to go ahead and write it in a different color. So let's say I was looking for the 13th percentile, right? So let me write it over here. If let's say we were looking for the 13th percentile, then that means that the bottom portion now is 13%. I don't know what x is, but I know that this bottom portion is 0.13. That's basically all it is. So whenever you see percentile, that will tell you how much of the percent of the data is below a value. So what we want to figure out is what is the value that represents 90% of the data that's below it, right? Okay, that's what we really want to figure out. So when you think of that, I'm giving you the percent, I'm giving you the actual probability. Now figure out the value, right? That is what inverse norm is. And usually, every single time I ask you for a percentile or a quartile, always use inverse norm if you want to go ahead and write it down. Okay, so this is going to be what? It's going to be inverse normal. Okay, so we already have our probability to the left. That's just 0.9. Okay, now we need to figure out our mean. Well, our mean is still 70 with a standard deviation of 10, right? Okay, and let's figure out what this is. Okay, so we're going to have second data. Okay, move it over here. Second data, distributions, inverse normal. My area to the left is going to be now 0.9. My mu is now going to be still 70. Sigma is still 70. What is my answer? My answer is now 82. So around 82.8. Let's say that. So this value, a score of 82.8, is already in the 90th percentile. Okay. So that's high. That means 90% of the data is right below you, right? So you scored among the top, up here, So that's just basically what it is, right? The 90th percentile, right? So these are the problems that I'm going to probably give you on the quiz on Monday or Tuesday, whichever class you are, right? So make sure that you know how to extrapolate the information, right, from a word problem into here. And be able to know when you use normal CDF and when you use inverse normal, okay? Whenever I ask for percentages, make sure that you always look for inverse normal. Now, be very careful, right? Make sure that you always draw a picture, right? I'm a very visual person. I like to see it to believe it, and I know a lot of you guys do too. So make sure that you draw a picture because that's going to make your life much more easier, okay?